Alright, welcome back. In this video we are going to look specifically at finding zeros of higher degree polynomials. And one of the places we're going to start is by looking at factorable functions. So when we're talking about finding zeros, essentially we're referencing the idea of the solutions to your functions. We like to call those the X-intercepts of the functions if they exist. Okay. Now, we usually write them as intervals or as integers. So what you have to remember when we're talking about x-intercepts, we are talking about the idea of x comma 0. Think back through to lower level algebra classes. So here, what does that actually mean? It means that essentially we're identifying the number of your term. So it would be, this would be your x value. Well, when we're talking about pre-calculus, a lot of times we see those same intercepts listed as c comma 0, where c, this right here, is the solution to the function. Okay. Now the concept is the same. We are still boiling it down and essentially looking at your x-intercepts, but now we're going to start using more general ideas and general principles behind it. Now, in the beginning, the easiest ways to try and find zeros would be to substitute that x value into the function and evaluate. So when we're talking about substituting, again, we're essentially talking about any random value, and as long as the function equals 0, then you can claim that that value was a solution. Okay. Now we have a new concept that we talk about a lot in pre-cal, which is called multiplicity. When we're talking about multiplicity of zeros, essentially we're talking about the number of times that that particular solution occurs. Again, this means we are talking about your x-intercepts. Now previously in algebra, usually that x-intercept would only occur once, but when you get to higher degree polynomials, you could have a particular intercept occur more than once. So we have a general rule. And that general rule says that if the multiplicity of a 0 is odd, then you're crossing at that x-axis. But if the multiplicity is even, then it's tangent or touching the x-axis. Okay, so meaning it touches the axis. So the way I like to remember it is like this. When we're odd, if we have a cute little graph, odd essentially means that if this point here was my intercept, my graph is crossing it. Okay. However, when we're talking about even, again, if we have our cute little graph and this was our x-intercept over here, then touching it would mean something along the lines of this is where we are, say, swooping. Okay, in other words, it's where your valley or your hill occurs. Now with that definition, we actually have an example of the way it works. So when we're looking at your functions or your equations, your degree here tells you the multiplicity. So here, when we're talking about your factor, again, remember we're talking about x minus c. The power of that factor tells you how many times it occurs. So in this case, I have a multiplicity of 2. What that actually means is it means that this factor occurs twice. A multiplicity of 3 is going to mean that the factor occurs 3 times. Now, every polynomial that we have, as long as your degree is greater than 1, will have at least 1 0, and at most n zeros. Okay, so we use that idea when we're trying to find our multiplicities. So let's look at an example here. First and foremost, we need to use substitution to determine if -2 is a 0 of the following equation. So what does that actually mean? What that means is that I need to solve what happens when I have g of x equaling -2. So this means anywhere you have an x, you plug in -2. Essentially, you would have -2 to the 4th minus a -2 cubed minus 3 times my -2 squared plus 5 times the -2 minus 2. And you just simply would solve this down. And what you're looking for is you are looking to see, does all of this become 0 or not? Okay. So we can go ahead and look. When we have -2 to the 4th, because my power is even, it means my negative goes away, and 2 to the 4th is going to be 16. Now, here I have 2 cubed, -2 cubed, so 2 cubed is 8, but because my power is odd, the negative stays, but negative times negative is positive. So this is a positive 8. -2 squared, the square is even, so this negative drops out. 2 squared is 4, times a -3 gives you -12. 5 times a -2 is a -10, minus 2. So then the question becomes, if I have 16 plus 8 minus 12 minus 10 minus 2, does that give you 0? And in this case it does. So we know that g of -2 equals 0. Now, that's not enough to satisfy the equation. The problem wants you to determine if it's a 0 or not. So you actually have to state your conclusion. Therefore, you would have to say, yes, -2 is a 0. Now you've answered your question. Okay. Let's look at another one. Here I have determined if the given value of x is a 0 of the equation, and that i.e. solves the equation. So my equation here is going to be x squared plus 13 equals 4x, and then my 0 is 2 plus 3i. So again, what we're telling you is that anywhere you have an x, you substitute 2 plus 3i. So this becomes 2 plus 3i squared plus 13 is equal to 4 times that 2 plus 3i. So now we simply need to solve. So remembering from algebra, in order to solve this first part, we have to FOIL it. So when we do that, you're going to get 4 plus 12i plus 9i squared plus your 13 is equal to, and in this case we would distribute that 4 through, and so this would be 8 plus 12i. My 4 and my 3 here can be combined together. And so here I'm going to have my 12i plus 9i squared plus my 17 is equal to 8 plus a 12i. Now with this, I can take my 12i and I can move it. So if I move it this way across my equal sign, I have 9i squared plus my 17 is equal to 8. Now the reason for that is because since my 12i is positive, to move it says I have to subtract. So 12i minus 12i is going to give you a 0. Now, in this case, I can also take my 17 and shift it. Again, it's positive, so this means I have to subtract. This gives me 9i squared equals a negative 9. At this point, we have to remember we have a very special rule. So the rule that we have states that I squared equals negative 1. So that means this gives me that negative 9 is equal to negative 9. Again, remember we have to actually draw our conclusion. Now, since this equation is equal, then the conclusion we have is simply that, yes, 2 plus 3i is a 0. This is your overall statement, and that is what's required to completely satisfy and answer your question. Alright, let's look at one that's phrased a little differently. So here we want to find the zeros of the polynomial function and state the multiplicity of each. So in this case, I'm giving you a polynomial. I want to know what the zeros are, and I want to know the multiplicity. So in order to do that, it says that I have to look at each individual piece as if it was its own. So the first thing that I have is I have 8x to the 4th, and that's its own part. I then have this x minus 3 piece, and then last but not least I have the x plus 4. So each individual part is going to be its own piece. So that means I have to set each part, so negative 8x to the 4th, equal to 0 and solve. I also then have to set the x minus 3 equal to 0 and solve, and the x plus 4 equal to 0 and solve. Starting with the first one, we divide everything by the negative 8, so I get that x to the 4th is equal to 0. So in this case, take the 4th root, and we know that x equals 0. If we look at that second one, we move the 3 over, so I get that x is 3, and we move the 4 over, so x is negative 4. We have found our zeros. So the zeros that we have are 0, 3, and negative 4. Now with that, we need to know the multiplicities. So not only did we find the zeros, but we need to know your multiplicity. So when we're looking at 0, we need to look at the degree that goes with it. So my first one, my degree is a 4. So when I have a 0, it has a multiplicity of 4. Now my next one is 3, so again I have to look at its degree. So here, when I have 3, it has a multiplicity of 2, because the power of 2 means it occurs twice. Last, I have negative 4. The power on my 4 is going to be 3, so this has a multiplicity of 3. It occurs 3 times. So when you are asked to find the zeros, you have to solve each piece to state your zeros, and then the multiplicity says how many times did that 0 occur. Okay. Now let's look at another one. So here I have an actual equation, and it has not yet been simplified. So the first thing that we have to do is we have to be able to break it down. So in order to do that, you need to use whatever factor rules you are most comfortable with. If you look at this first one thing that you could use would be grouping. Why? Because it has 4 terms. Grouping says you're going to look at your first 2, and then you're going to look at your back 2. Okay? So here I have x cubed minus x squared. So this is going to say that I can pull out an x squared, which leaves behind an x minus 1. In this back, I'm hoping that I create x minus 1. So the first thing I would do is pull out the negative. It's going to force a negative into my factor. And then I can pull out a 2. When I do that, I get x minus 1. Because my factored pieces are the same, it means that I can rewrite in that I have x squared minus 2 times x minus 1. So now, in this case, I have my two factors and I have to find the zeros. So that says I have to take each factor. So I have x squared minus 2 equals 0, and then I have x minus 1 equals 0. So I need to solve each factor. So x squared equals 2, so x equals plus or minus the square root of 2. And then over here I have x equals 1. So when we're looking at the zeros, we have plus or minus the square root of 2 and 1. Now the other thing that you can notice about them is notice the powers on each of these factors is a 1. So here we have that all have the multiplicity of 1. Okay. Alright, let's look at another one. So here I've got a quadratic. I have x squared minus 2x plus 5. So the first thing I need to do is I need to figure out what its zeros are. So in order to do that, first you recognize that it cannot be factored. So the smartest thing to do here would be to use the quadratic formula. Anybody who's forgotten what the formula it is, remember it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So what you're simply going to do is pull your coefficients off of a, b, and c, plug it in, and solve. So in this case, we would get that x is going to be 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 5 all over 2 times 1. Once you write your quadratic formula, you want to simplify under the radical first and then reduce from there. Once you do that, you should come out with having x equals 1 plus or minus 2i. Now, just in case you need a quick mini refresher, when we talk about under the radical here, negative 2 squared is going to give you 4. 4 times 5 is 20, so this is minus 20. 4 minus 20 is going to give you a negative 16. And so when you do that, what happens is you ended up getting 2 plus or minus the square root of negative 16 all over 2. In this, the negative is going to pull out of your radical as an I. Square root of 16 reduces to 4. So this here is going to become 2 plus or minus 4i all over 2. And from here you would reduce. 2 over 2 becomes 1, 4 over 2 becomes 2, and thus we end up with your 0. Okay. So in this case, we have what are called complex zeros. So here we have a complex 0, and that is 1 plus or minus 2i. Now with that, it also means that we all have multiplicity of 1. Okay? Because each 0 only occurs once. Now how do I know that? Because this is quadratic, and quadratic can only have 2 zeros to begin with. Now, if we look at this next one, notice I have an x to the 4th, so the first thing that I need to do is move my 8 over. So this becomes x to the 4th plus 7x squared minus 8 equals 0. Well, this, because I go from x to the fourth and step down to x squared and step down to x to the 0, this can actually be factored fairly easily. I can break this into its pieces, and this becomes x squared plus 8 and x squared minus 1. Each of these needs to be solved for x. So I'm going to have x squared plus 8 equals 0, and I have that x squared minus 1 equals 0. In this first case, I end up with x squared equaling negative 8, so x equals plus or minus the square root of 8, I off the end, but the square root of 8 can reduce, and so this is actually going to become that x equals plus or minus 2 square roots of 2, I. Now on the other side, I have that x squared is equal to 1, so x is equal to plus or minus 1. Now, if you notice I started with x to the fourth, it means I should have 4 zeros. So 1, 2, 3, 4, I have them all. In this case, again, it means that my zeros are going to be plus or minus 2 square roots of 2, I, and plus or minus 1. Again, because they only occur once, it means that I have a multiplicity of 1. So that's everything that you need to know about higher degree polynomials, solving for their zeros, and stating their multiplicities. Remember, multiplicity simply means how many times did that zero actually occur in your polynomial. So if you have any questions, please let me know. Otherwise, I'll see you next time.